Hello, my name is Bill Zhao, and today I'll be making a video on optical telescope making. Before I go on, I'd like to mention that this video is a shorter summary of a longer paper I wrote concerning the same subject. All the sources and references I use can be found in that paper. Before I go on, I'd like to talk about the history of telescope making. The earliest telescopes were effectively made from small tubes with a glass lens inside. The lens would focus incoming light onto a smaller point which could be viewed through the back of the telescope. These telescopes, while more powerful than the naked eye, had one serious flaw, which is that they suffered from chromatic aberrations, which is when different wavelengths of light would effectively focus at different points after they traveled through the lenses. This limited their power. Multiple attempts were made to boost the magnification power of telescopes. The first was to increase the focal length, but this method was very impractical, as eventually telescopes got so long that they would basically collapse under their own weight. This second method was to basically just ditch the telescope tube altogether and make the lenses and the eyepiece two separate objects. Because of this, they could be placed as far apart as the astronomers desired. However, at a certain point, the amount of time needed to calibrate and align these telescopes got so long that this method also became impractical. Instead, Newton discovered that light behaves like a ray, and he discovered that when light reflects off an object, the angle at which it reflects off said object is equal to the angle at which the light approaches the object. Using this knowledge, Newton was able to manufacture a telescope using using curved mirrors to reflect all of the light towards the viewer. Because these telescopes use no lenses, they did not suffer from chromatic aberrations, which made them far more powerful. Later on, opticians realized they could fix lens-based telescopes by effectively stacking multiple lenses on top of each other in order to correct for the different wavelengths of light. Basically, the lenses would cause any incoming wavelengths of light to focus at the same point. However, these telescopes were far more time-consuming and expensive to manufacture, which is why reflective telescopes ultimately won out. As time moved on, telescopes got bigger and bigger in order to increase field of view and magnification power. The most famous of these early supermassive telescopes was William Herschel's 40-foot telescope, which was built in 1789 and had to be mounted in a rack, in a special frame. Later on, in the late 19th and early 20th century, scientists like Max Planck discovered that light behaved like a wave and the energy of any beam of light was proportional to the wavelength of the light inside the beam. Using this knowledge, scientists realized that different objects were likely emitting different wavelengths of light that could not be seen by humans. As such, scientists began modifying their telescopes to view objects in different wavelengths. By doing this, they were basically able to see structures or other objects that could not be previously seen, as the wavelengths were either too faint to be seen by the human eye, or they were getting absorbed by objects in the foreground. This led to many more discoveries. And as such, most modern telescopes today are able to look at distant objects in multiple wavelengths. Speaking of modern telescopes, this is where we move on to how telescopes are made today. Most modern telescopes are made from large mirrors that are multiple meters in size. They are made using two methods. The first is to basically piece together many smaller mirrors into one massive one. However, this has the issue that it takes a lot of time and energy, as you need to basically align all of the small mirrors correctly. The second method is to basically make one giant mirror, but this is extremely expensive and requires a lot of expensive machine tools. So the smaller mirrors that are basically built like regular mirrors, except they are machined to the standards that the telescope owners desire. And the larger mirrors must be made in a different manner. These mirrors are effectively spin casted, which means that while the mirrors are being molded and cooling down from a liquid to a solid, when the glass that the mirrors are made of are cooling down and turning from a liquid to a solid, they're spun around to ensure that the mirror ends up forming a parabolic shape. This reduces the amount of machining needed. These mirrors will be then checked and coated with metals to increase their reflectivity. After these mirrors are done, they'll be moved to the construction site to be mounted in place. Because of how massive these telescopes are, people obviously can't just look at through the back of these mirrors like older telescopes, and the light must be vented through multiple secondary mirrors. Thank you for watching.